please see our screen?
Yeah, it's visible.
Perfect. Yes, so today's webinar basically is about data explainability. How do we understand data? Because we know that data is used in every platform, and in this world of the fourth industrial revolution, data is kind of the engine, it is the oil. So we must understand data. And then again, how do we make use of it? So there is that science behind data. For example, we say that data is made up of raw facts. For example, I can say 100, 200, or apples. That is something that is not processed. And every single day, we get to interact with it. Another thing is that how do we connect our data with science to form data science? Because remember, we have to use that which called bottom-up approach from the beginning, from the bottom. So now, for example, like if we process our data into information, now it gets a bit of meaning. We can get insights from there. For example, I said, I sold 100 apples. That's a processed information. We can understand what it means. So when we connect data and science, basically, we are able to make decisions and at the same time uncover unseen patterns. So that's the link between data and science. Now, in a typical data flow, for example, you always have your input, which is your data. And then again, you do a bit of processing. In this case, it's a wide field. Might be cleaning, might be manipulation using various techniques of your own. And now you get your output, which will be consumed by the user. So in many cases, I've seen that many data scientists always ignore the user, who is always the end consumer. And in this case, we should always make use of the consumer, because at the end, we have to make human-centered approaches in this case. Yeah. So now, how do we use our data daily? And my colleague will explain that.
Yeah, so one question usually we get a lot, like people will be questioning the big terms, and then they ask themselves, oh, this is a very complex concept. But in our daily life, we've been doing countless of decisions. For instance, you have to catch a bus. So you are considering basically the timing. Do I have enough time to reach a bus station? If I have this time to use this bus station, which bus should I catch? These are decisions. And these are basically the set of analysis we are doing on data daily. And let's consider as well what to eat, when to eat. So you have your break, your timing, your break, when to eat, when do I have lunch, what do I want for lunch, and I've eaten. Let's say you are someone who is doing gym or those type of fitness exercises. You are timing yourself on different type of calorie intakes and all this. These are decisions you're making also on data and information. And also you have goals. You want to, for instance, stay fit on a particular time or timeline. So you are setting a set of goals and what to do to achieve those goals. So now that we know that there are different ways we are interacting with data in our lives, so are we all expert in disguise? So does that mean that everyone in certain sense has been doing a bit of data scientist without knowing it? So let's consider a simple case. So I'm from the Caribbean island, so I do a lot of interaction with, I would say, fruits and those type of things. So I'll consider an example of avocados, and maybe some people in the audience might be familiar with this. Let's say you go to a supermarket, or even like in the village, wherever you are from. So you get to purchase avocados. So when you get there, one thing you might want to do is like you have the vision to explore, okay, these are the avocados. Are they looking good? If they are looking good, which ones I'm going to select? So you're making decision on the vision. So we are talking about here the concept of modalities. So what do we mean by modalities when it comes to exploration of data? Modalities are basically the different senses. We call them usually senses, like you have vision, you have touch, you have hearing. So let's consider the example of avocados. Let's consider we don't have the perfect avocados. We are in Ireland. These are considered as large avocados. So these are basically avocados. Let's say you had a pile of avocados, you have to decide. So when you reach there, the first thing you do, you use your sense of vision, your eyes, you analyze what you see. So this is a first interaction with the information or data. The information is you need to purchase good avocados. So now the data is you have avocados available. So now, how do you select the avocados? You first start by analyzing with your sense of vision, your eyes, you analyze. So you've identified 2 avocados in the set. So are they good? So when you turn them over, you saw that, oh, they are slightly different. One is more, I would say, rotten, and one is, let's hypothetically think that this one is a good avocado. So you said this one is bad, this one is better. So how do you do this? Is because now you've used your sense of touch and other sense of modality to interact with this information, with the data itself. So basically by turning the avocados over, using this other sense of modality, you get to get more insight from this data. And this is what usually we say, that when you're doing any piece of data analysis or data science in our daily lives, like when you're interacting with data, what you're trying to do is basically getting insight from the data. Sometimes those insights might be hidden. So in our case now, the previous example with the avocados, we were exploring 2 sets of modalities, the vision and then the touch. Well, basically, were these modalities enough? That's one question we might ask sometimes. Let's consider now, you are tasked to purchase now a good coconut. With the avocados, you could touch them, you could press, you could see whether they are good, you could visually see whether they were good or not. But with the coconut, when I have this coconut, I can't open it. The only way to know it's good, I need to open it. But can I open it without purchasing it? It's not wise to do. So how do you make decision now on this case? So to make decision on this information, to process this data, you need a further exploration of modality, which means basically interacting with this information, this data in another way. So that's when now vision and touch is not enough, because I can still see the coconut. I can still touch it. There's a weight to it. But is that enough for me to decide on my purchase? I can't. So therefore, I'm introducing another modality, another sense, now the sense of hearing. So I'm from the island. One way I grew up seeing people, doing this is basically when you have a coconut, when it is very full and it has the water in it when it's full, you can shake it and hear from the sound whether it has a lot of water inside it or less water. So it means that more water, we know that, okay, it's a very fresh coconut, and less water, it's getting drier, which means that the quality is decreasing. So it's more towards oil. So it's not something you can consume normally. So this is informing me on my decision-making process now. So this is now another modality we've added to make decision on the data or explore the data. So we've all been doing data analysis in some cases in our daily lives. But now one question might be, okay, is it enough when we are dealing with one coconut, 2 or 3 avocados? So what if we have tons of data now?
Yes, for example, let's say you have got large piece of data, right? Coming from coconut industry, for example, or the revenue industry. So that means that you need a more complex analysis to get more insight, for example. Yes. And now that will take us to data modeling. How do we organize our data? How do we document it? So that now we can be able to get insights after our proper manipulation. Now, I will briefly touch on time series. Time series data. Why is it special? Number 1, it is temporal. What does it mean? We calculate data or pick data or sequence of data at successive points. That's number 1. And number 2, we have a bit of autocorrelation. Let me give you a very simple example. We all love and like ice creams. So let me say, today, we have got very high temperatures. What happens? Most likely, we shall have high sale of ice cream cones, most likely, right? When we have 10 degrees temperature, high sale of cones, 30, 40, that way. But now, let's say you want to see the number of cones sold against temperature. That is linear, but that is not time series data. But now, how do we apply time series in this case? For example, let's say if you want to forecast the number of cones which will be sold today as compared to the number of cones sold yesterday. So now, in that case, we are trying to make time comparison between today's sales and yesterday's sales. That is time series forecasting. So we use it every single day. And again, let's say we are trying to predict GDP growth in a country. We look at many factors like the rate of inflation. Or let's not go far. In the healthcare sector, let's say you have got patients coming in, out of the hospital. So again, they have got some specific or successive symptoms. Now, those symptoms, for example, can lead to a specific disease prediction and compare today's symptoms with yesterday's symptoms. That is time series prediction and forecasting because of its autocorrelation and its temporal kind of feature. That's why it is special in its own way or the other. Now, to understand all this of forecastings and predictions, we go to machine learning. What is a machine? How do they learn? Why do they learn? And why is it important? So, for example, let's say if you write a simple program in a machine, and then you give some specific instructions of what will be done, like do A, B, C, and D, right? You've given the instruction in this case. So in that case, this is not machine learning because already you have given instructions of what has to be done. But now in machine learning, we just give data into the machine model. In this case, we give those raw facts, those raw features. And now from that, we get insights from it. For example, you can have features, let's say, for example, of X. And we say X will lead to something like Y. For example, let's go to the healthcare sector or system. And when a patient got into the hospital, we have got several, features for example, like let's say blood pressure, sodium level, iodine, etc. And we can say these features can lead to something like Y. In this case, Y can be either death, which is mortality. Yeah. So in this case, machine learning will be able to extract features from your input data and now predict the possible outcome. You have not given instructions. You just give your data. It will do its abracadabra behind the doors and then give you a proper outcome based on what you wanted. So, the aspect of machine learning uses the art of the brain. For example, we all interact with it. We cook every single day. So let me assume like I touch a hot pan using my hand. You can see my hand. So the heat here becomes my input. The heat becomes my input. So what happens? We have transfer of signals. Sensory neurons, we come to motor, we come to relay into my brain system. What you can see here. So the brain has got several nodes, which now will make decisions that this ant is on fire. This guy is getting burnt. So now the output will be pull your hand from fire. We call them knee-jerk reactions. So the brain has been able to make decisions of my hand from fire without my knowledge. So that's how machine learning models work. They use the aspect of the brain Remember, the brain has got nodes. The same case too. Machine learning models. They are the ones which process our features. They extract everything we require. The same case to our brain. It does so. It's our engine. So that's how brain compares to machine learning models. Now, if you look at this sample machine learning model, it has got connections. You can see connections in several nodes. The same case to our brain. We have several node connection. Same case to our model here. So that's how they are correlated. So if you look at the left side here, we have got our input data where we put our raw facts. We don't program or give any specific instructions. We just get our model and then pass our data into the model. What happens next? We have these nodes, you can see, for example, like the way they are arranged here. Those nodes now, what happens is that they extract features from that data. And then now from the features, we're now able to get output as Y in this case. So for example, this is a sample of what we call a feed neural network. We have your input, you have your nodes. And these nodes, which are so many, we call them the hidden layers, like our brain. That's where the actual feature extraction occurs. And now, again here, we get our output. But now the question is, do we understand what happens in the nodes? Do we understand why some specific nodes are used or not than the others? Why? Why that science? It's not rocket science. That's where now the issue of explainable AI comes in. We are trying to understand what happens in these hidden layers, in the black box, behind the curtains, in the backend, because as a user, you have to understand why to use this model and what happens in that specific model. For example, let's say in this case, in your X, your input, let's say, is a green image. Let's say you are doing a simple image recognition, and then you input your green image here, and then what happens is that the very first nodes might extract features like the edges. So your image, edges will be extracted. We have that properly. And then we go to the second set of nodes. We'll extract more advanced features. And now the third set of nodes might start to extract colors. But now this node might be only keen on green color. The second node might be keen on blue color, yellow color, red, etc. And then at the end, you get a prediction of a yellow color as your image. Remember, your input was a green image, but your output here, you are getting a yellow image. Why? Because some specific nodes have been selected. Not all nodes are used, only some are used. So now the question is, do we understand why some nodes are preferred than the others? That hidden processes, that's where explainable AI comes in, trying to decode what happens in this set of hidden layers. Now, if you look at this slide here, I've used a simple image of a lady called Lena. Lena is a very popular image used in machine learning. And you can see that we have a matrix of images. Some of them are a bit clear. Some of them you can see a bit of their edges. Some of them are black, some of them are a bit blurred. Why? Because of the nodes which has been able to detect them or to extract their specific features. Yeah. So now the question is, why does this node extract a clear image than another node? We have what we call parameters in machine learning. Basically, the best way to explain a parameter in a machine learning model is those functions or those aspects which enable you to tweak your model to get better results. They kind of enable you to tune further, to adjust further to get better results. So basically, I've just given a sample of Lena images and how they are being processed by several nodes in a model. Now, let's say we got a final output of this. This was our first image, our input, but at the end, we got a learner image which is not clear as per our expectations. And in this case, for example, someone might say, my model has got 98% accuracy, but good people, if you look at this, can you really rely on accuracy to say that your model is good? I would say no, because your processed image here is not very much clear. We should see a clear image, a clear learner image. So again, which other techniques can we use to understand predicted data in a machine learning model? Because to be honest with you, good people, many data scientists only rely on accuracy. They will say, my model has got 90% accuracy, and people will clap for them. That's good. Yeah, it's good. But is it enough? I would say no, biased. So we need other mechanisms to enable us to understand our data. Let's say, for example, you are dealing with numerical data now, not image data. In this case, for example, you can see we were doing a bit of ICU mortality prediction, and we have been able to come up with a very clear confusion matrix between what the model gave us and between the accurate values on the ground. And the question is, you can see we are having a bit of false negatives and false positives. And again, the question is this again clear enough to say that my model is enough, or is kind of secure enough, or is really good enough to be deployed? The answer is no. Okay, assume again you were using, let's say, text data. And text data, basically, this will take me to data mining, for example, where people will go to Twitter and scrap some data, you know. For example, let's say nowadays we are in a campaign mode in many countries, politics and such stuff. Let's say, for example, like you want to know the commonly abused word, right? And then you are a machine data scientist, engineer, or etc. You make your good model. That's fine. At the end, you come up with what we call a word cloud. After doing what we call stemming, trying to reduce words, lemmatization, etc., you know those things. Yeah, because remember, in text data, you don't directly visualize the output like this. You need to do some processes there. You first of all need to cut some words, you know, to be in the original lemma words. So if you come up with this word cloud to give to the consumer, the question is this enough, again, to come up with proper decisions or insights? And I would say again, no. So how do we interpret models? And research shows that the higher the model has got a higher accuracy, the less the model is interpretable. Why? If you look at this specific graph here, deep learning models here, they have got so many layers, right? Because they are so much complex. They get so good features. They have got high accuracy. But because of their complex nature, it's hard to interpret what happens behind the curtains. For example, if you look at linear models, you know, linear, you just relate X and Y, for example. They are very much simple. They have got low accuracy, but it's easier to interpret the model. So now that's why we need to understand about model explainability, why we need to understand hidden layers in a model. And that takes us to explainable AI. Why is it important? Yeah.
Yeah, and that's a pretty good actually example that the more we have in complexities, you know, adding more parameters. And nowadays with LLM, I think Facebook and even like OpenAI, they are all releasing new set of large language models, which have basically, you know, billions of parameters. So let's just take a step back. So in order to understand this, Alex had to give a set of examples just to explain what is going behind this process of AI decision or decisions in general on data. So imagine you had a model with billions of parameters. How do you even explain this? You will need a full lecture on what is happening behind this model. And if we are considering basically human applications, like let's say in our daily lives, you don't have time to have an individual explainer on everything that is happening. So there's a need there to have systems that can have self-explanations. Basically, it makes it easier for people to understand what is happening behind the scene. And in the AI decision space, we call it AI decision space because we are talking a bit more in our context for, I think, data science, which is basically informing decisions mostly. So it's very important to put, first of all, human at the center, because we had, in the very beginning, you had your input, and then you had your output, but there's a need to close that loop, to connect the input with the output, which is basically having a human-centered, we call it human-centric aspect, which is basically everything revolving around human. So we are building system, we are making decision to inform human. So not just creating system for the sake of creating system, but at the same time, being able to do two important things. Basically, we can explain the process of those decisions. Why did we do those decisions? And also explain the interaction with the system. So in certain cases, do a certain type of interaction influence, basically, does a certain type of interaction influence the system itself? So, which is two important things. And that's where we have explainability or explainable AI in many cases. So now that we are talking about explainable AI, so what is the current research space or the current state of explainable AI? Where are we with explainable AI? So we said that nowadays there's a huge focus now because we've seen so many things going on now. We have mass influence going on social medias, and many of those social medias, they are using AI. We have other systems. We have this also in healthcare. So in Europe, for instance, there's a GDPR, which is the General Data Protection Regulation, which basically is kind of defining basically how people should be interacting with data. What are the responsibilities for the different stakeholders? So that's why now for having responsible AI system or responsible system manipulating data, there's a need to put human at the center. So therefore, we need human scrutinization. Basically, humans should be there at the forefront, both in the development of the system, but at the same time, evaluation of the system, not just creating the system and then generating the output for human, but at the same time, evaluating this process to make sure that iteratively it's correct and it's not generating any harm or any other consequences. And that's why we say we scrutinize the system. At the same time, we have to intervene as human in the system. And to do these now, in terms of the research space or state of the art, both in industry and also in the academy, which is basically the word Alex and I, we are evolving, there's a focus on what we call toolbox nowadays. Like a set, by toolbox, we mean the same way you have a set of tools, and you can use different tools for different cases. So let's say you have a case that requires a specific set of tools. You can reuse the same tools for different purposes. And that's why they call it explainable AI toolbox, which means that a set of tools depends on the case scenario or different on the system or the decision-making system. You will use different tools to explain what is happening within the system. So since we are talking about human-centric design or human-centric decisions, so we have to put human at the center. Therefore, one of the key aspects in explainable AI is we need to understand what are the people's needs. Because if we want systems to respond to certain needs or to certain problems, basically, as your role as a data scientist, you have problems and you have the data, you're trying to extract meaning from the data, and even in certain cases, inform certain decision based on this data. So therefore, you're not just using any technique because they said these techniques have been used and applied. You have, as Alex was saying, you have a high accuracy on this. Therefore, this is the right thing to do or the right decision to make. But therefore, you need to know what's your end user's goal. So what are their needs? So if you understand their needs, therefore, you can embed in the whole process of developing those systems the specific, I would say, focus and answers to those needs. So in the current state of the art, I would say, of explainable AI, we have what we call it, we started with explainable AI algorithms. An algorithm basically is a set of instructions that are needed to achieve a specific task. So initially, we had what we call directly explainable model, which is basically the way we are doing it, trying to have explanation on the model, just giving an explanation, overall explanation of the model. But these were not enough. So therefore, now we have a new research space called post hoc explainability, where we have three main categories. We want to understand basically what is happening behind the scene. By behind the scene, within the nodes, as Alex was saying, what is happening within those nodes, and can we actually identify the patterns within those nodes? So, which is basically going deep inside the back end of the system, kind of exploring inside those black box. That's why we use this term a lot for AI. We say that AI is basically a black box because you just get the input and then you get an output, but you can't see what's going on inside the black box. And that's why in certain cases you will hear this term a lot: garbage in, garbage out, which means that if you have, as we know, bias in your data in the very beginning, it generates bias in the end as well. We have countless of systems like this, system denying loans for people in certain minorities. We have system, for instance, doing false detection for Black people for cancer. You have all these because the data being inputted into the system has already been biased itself. So therefore, we are getting a bias end result. But we can't explain this and we can't see where this is happening because there's a black box effect on the AI itself. So that's one area being explored. So another area that needs explanation as well is why did the AI make this decision? So we have now, as I was saying, the feature importance, why a specific feature and not the other one. So explaining this decision making, why did I get this loan and that? And now there's another aspect. Now, if we know, basically, we explain the process to make that decision, we say that it's good. Now there's another one which is basically counterfactual. So why I didn't get this loan and why you said I was refused. So it's kind of the counterintuitive approach where we are questioning now why this one and not this one in terms of the prediction itself. So there are a lot of research going on, and one good documentation on this is this paper reference here, which gives a very in-depth understanding, I would say, intro to explainable AI and also explainability in data itself, so which you can explore. And now, if we are talking about human-centric AI design, so we need to understand now our end users. Basically, who are those users for those systems or explainable systems that we want to create? And one of the first users basically are the model developers themselves, like people like Alex who are constantly building those models. Alex is dealing with EVs and making accurate models for such predictions. So he needs to understand why, for instance, his model was not accurate and why did it fail in certain cases or not. So these are called basically debugging systems. So it's like in the normal classical programming space, when you build a program, for instance, like Facebook, you are building a program like Facebook. If there's a bug, something crashed, you can't log in, you need to know why this user couldn't log into the system. So this is called a debugging process. The user the user itself doesn't have to know why it failed. You can give an explanation, but for the developer itself to be able to fix this, the developer needs to understand what is happening in these cases. So it's the same now in the AI research space. There's a need now for people like Alex who are developing these models to understand now where and why such models are failing in certain cases. So we have some example of tools. So we have explanatory tools, debugging tools, Gamut, and I think IBM has been doing a lot of research in this space. Google also is joining as well. And now another important group now is decision makers. And for people in data science world, this is very important because many of your decisions basically are needed to inform certain stakeholders on their own decisions. For instance, you will produce your own analysis, and then you present those analyses to, usually it would be someone in the decision space who will have to make a say or have a say on this final piece of information. So there's a need now for this personnel. So for you to explain why you're leading to this specific decision. So we have example of system, for instance, there's a model, an example of explainable system for decision makers where they're trying to assess, for example, the loan risk assessment. So they assess the loan risk for people, let's say in the bank sector. So that person making the decision can actually not just say, okay, the AI is telling me I need to refuse this person the loan, but at least they can evaluate those risks and be more informed on their decision. So we'll talk a bit more about this on this trust on the AI and a bit later. And the final group that is often neglected, not just in the data science world or AI world in general, even in normal user experience, normal application development, we'll always ignore the end user. Because it will be, I built a system, the system does this, I've tested the system, therefore it's good. I built a system, I created a model, the model is this percentage of accuracy, therefore this model is good. But we often ignore the end user. It's only at the end, after we've developed and create those confusion matrices, those techniques, we said that now let's bring it to the user, which is often not the best thing to do, because as we say, we are trying with explainable AI to do the opposite. Understand the user's need, embed those needs within the development process of this AI process itself, so that we know that at the end, those questions they might have been answered through this process already. So we have customers like, let's say someone who was refused a loan, this person now can understand, why was I refused this loan? Not just, okay, we refuse you this loan. The system said you're not adequate for this loan, but why was I rejected? And also for a business owner, okay, why didn't I get this loan or this particular risk on my loan assessment? So it's important for them as well. So it's often a group neglected as well. So now that we've seen that the user is very important, so one piece of research which is, I think, very good to explain how people are trying now to embed explanation into AI decision is basically this research done by, I think, Vera in a group. So they try to create what they call a mapping of user intention. So by mapping of user intention, what they did, basically, they created a set of questions. These, they talk to data scientists, designers, and model developers and users. And they say, okay, what are the questions usually people ask based on certain cases of AI or certain cases of certain decisions? And they categorize those questions into groups. And they say that these groups basically are part of the toolbox. Remember, we talked earlier about the toolbox. So the toolbox is basically those different tools you can use and mix together so that you can create an output that is tailored to a specific need. So in this case now, it's a system. They run a demo with a system for healthcare where they were trying to explain the decision or the risk in certain healthcare scenarios. So what they were doing, basically, they have their initial questions the end user might have. The end user in this case, it might be the clinicians, it might be the patient itself, it might be also the designers of the system, it might be the data scientists creating those graphs, the specific graphs on the risk prediction. And those questions now, they use the toolbox and selected questions that the user might ask, and then now they build the system while having those questions in mind. So that's why now they try to match different section and different, I would say, in this case, visualization or representation on the system to specific set of questions. So that's an approach they've taken to try to create, I would say, explainable AI or explainable decision making. So these are basically techniques still in exploration in academia. It's not things that are mainstream because, as we say, it's still a black box. And these are ways people are trying to do what we call nowadays not just explainable AI, but human-centric explainable AI. Because it's not just about explaining why it failed to a developer. It's not just about explaining to the decision makers why they can't accept this loan or what are the risks for the bank itself, but putting the user at the center. Because even if it is the developer, the impact is on the user. Even if it is the decision makers, the impact is on the end user. So therefore, we need the user at the center. That's why we say it's human-centric explainability. So now that we see that adding explanation basically can create basically a sense of trust in the system, because people are feeling more compelled, more integrated into the process itself. But one question now could be, does explainability have an impact on the trust? And we've seen that according to research, now that we have system now trying to add more explanation in the decision. Let's say the system says, oh, this person, based on the brain scan, this is most likely to be a brain tumor. And we are 95% accurate on this because the selected area has shown a diameter of this and this, which is similar with other cases and everything. The system is giving this additional explanation and rationale to the clinician, which is good. But now, let's imagine now the system has been given several cases which are good. Let's say one day the system has given something that is not right. So they found that people now are becoming more reliant on the AI itself because they know, oh, the AI made the decision, it explained it, therefore it's good. This is a problem now. And also it creates a sense of overconfidence because now that you've read basically the explanation, you say, oh, it has been explained. And now we've seen in many cases, we were talking about this earlier. So another case which is very prevalent basically is what they call placebo explanation. So what is a placebo? A placebo in certain cases is, as a data scientist, in certain cases, if you're running an experiment, you might have this. You might have a group, what we call a control group, which you give an experiment that is not containing the effect you want to explore. Let's say it's a pill, like a medicine. You might give that medicine to one group, and then you give that medicine to another group. And then you analyze the data from the group. You don't tell the participant that you've given them the placebo pill, which is basically the pill that doesn't have any effect. But the patient know basically they are taking the same pill. And then you, as a data scientist, you're going to evaluate the group which you've given the right medicine and the one you've given the placebo, which is the fake medicine, which doesn't have any effect. Does the group with the placebo have a better response compared to the group which has been given the right medicine. So this is called a placebo controlled experiment, where therefore you can confirm that in fact there's a better or high or increased effect with the group which has been given the right medicine. So that is called a control experiment. I'm not going to go into the details of this. So the same is being used now in explainability, and we have we call it placebic explanation, which is basically when the AI doesn't know what to give as a proper explanation. It just tells you, I basically gave you this explanation. I basically use this process because it's needed in the system. It's an explanation, but is it the good explanation? Technically, it's not telling you anything. But the fact that it's given to the end user, it creates confidence in the system because it says, this is important for the system to work. We wouldn't accept this. You would accept this then. So therefore, this placebic explanation, which is this fake, useless explanation, although you're given an explanation, is creating overconfidence in the system. So therefore, people now are not engaging now in those explanation. By engagement, what do I mean? So by engagement, I mean that people now are not checking those explanations. So therefore, they are saying, it's true, we are human. So if you've used something several times, we learn as well as human. You've used something several times. Even if, let's say you've used this 5 times, it has been correct. I mean, the 6th time, I'm sure you'll be less to worry with it. So it's the same thing. So now there's a bit of overconfidence on this, and that's why we are saying the problem now with as well, we are moving to a system that needs to provide better explanation. But now we can't trust human. Human is always a problem, and that's why we say human should always be at the center. It's not because now we're adding explanation, it means that, oh, therefore it's good. There's no need to evaluate those methods. So we need to be cautious of this because now we know that we are dealing with human, and whenever you have human in a system, there's a risk. And that's the reason now we are saying cognitive engagement. So the word cognitive here is very important. By cognitive, we mean that anything that is involving the senses. For instance, someone might feel a bit tired that day. So they just read this explanation saying that this patient has the tumor. They read it halfway and they said, oh, this sounds good. I don't need to read the rest. I'm already tired, exhausted. And even with explainable AI now, another issue is, what if we give too much explanation and then cognitively we are overloading the user? Too much things to read to understand this. So imagine now you have to do this over and over. So that's now where we have a pitfalls with this. So where do we balance this? And that's where the current state of research is kind of still evolving, I would say. So now that we see that, okay, there are a lot of problems there's a need to provide those explanations. And by the need to provide those explanations, we are talking now, as we saw in the previous slide, we have the input, we have the processes, okay? We saw the processes, the machine learning, decision-making and everything. And there's a need for an output. Yes, we are looking towards this output. We are given explanation. But how those explanation or those outputs, are they accessible? And that's a question often data scientists or even in other fields as well, people are usually not focused on that. So is my end result accessible enough? By accessibility, what do we mean? So by accessibility, let's go back a bit. So there's this concept of digital divide. And I came from Haiti. So Haiti, I'm sure Kenya also has struggles regarding, digital literacy and digital access to technology. And this is called a digital divide. So digital divide is basically, it has 2 layers. So you have basically people who don't have access to resources. When by resources, people who don't own a smartphone. That's our first layer. But what if now someone has a smartphone, but they only know how to make a phone call on it. Or in typical case, on my parents, for instance, it would be, they know what to do WhatsApp, share something on WhatsApp, but that's it. So this is now digital literacy. This is a second layer of barrier, I would say, of barriers on access or understanding or gaining understanding of information in general. So your role as a data scientist, of course, you have this huge chunk of data. You use set of techniques. Now you know that it needs to be it needs to integrate explainability so that people can understand it. But now you need to convey those decisions to your end user, because you said that end users were basically at the front line of those exploration. So now you're providing these to your end user. Are they those methods you are using, are they accessible to those end user, your targets? Are you basically tailoring your presentation of your results to your audience the right way? And why am I heading towards this area? Is because this is kind of my main area of research right now. There's a predominance on visual cues. By visual cues, remember we say cues are basically, in simple terms, the senses. There's a predominance on the vision. So it's everywhere. When even right now we are presenting those slides, it's a PowerPoint, and it's only people who can see and can't right now. But we have hearing as well, which is good. But what if someone can't see? What if someone can't actually touch, doesn't have the sense of touch or something? Are there other ways we can convey this? But basically right now, the predominance is on visual cues. How do we present information generally? Conventionally, we present information basically, your graphs. You present a graph. The graph has color. It has different patterns in certain cases. You use dotted line to show your different, let's say your trend and different trends. You would use those as patterns. But are these in your end users or your presentation or data visualization as a data scientist? Are they accessible to your audience? What if now you've done a very nice piece of analysis, you've made a decision, then now you're presenting this decision to the decision makers. What if someone on this meeting board is blind? How do you present this to someone that is blind? Can you, will you be saying, as you see on the graph on the left, the yellow graph, they can't see? So how do you present your information to audience? That's a bit that is often neglected in data representation or the way we convey information. We often we spend more time in the analysis, and then we just say, this is my end users, as seen on the graph here, as seen on the label. Even things like a label can change a lot in this. And one stat, we didn't put it on the slide, but one stat that is very important, the world population is aging. So the world population is getting older and older. And this is very important because we know that this is sign of, as we get old, we are more prone to what we call age-related impairments, which is basically you lose vision. I'm this age now, and already I'm wearing glasses. So the next if I'm living longer, so in the next 10, 15 years, my eyesight might even be the same or even worse. So imagine you're getting old and you are facing all those risks in terms of age decline or age-related impairments. Your sense of hearings as well is declining. So how do you now create data visualization or data representation, or you convey your information in ways that is accessible? That's the biggest challenge. And that's why we need to move from the typical visual focus. And that's where, in the very beginning, when we were saying that, we were taking the example of the avocados and the example of the coconut. These were not just examples. These were announcing basically this area, which is often underlooked, which is basically data accessibility. So are my basically, is my representation or my final end result or my final dashboard accessible to a wide range of users? Because if you're considering you're working, for instance, for the government of Kenya, in case as a data scientist, you're a very brilliant data scientist, and now you're making decision on I follow a bit the Kenyan political space with Alex here. So let's say you're making a decision on your latest bill, and then you just said, "Oh, okay, people will be paying this and this in taxes," but people don't even understand the rationale behind it because there's nowhere they can accessibly check these informations to understand them properly. It's not, maybe the decision is right, maybe it's not right, but are the explanations, are the way, is the way we are conveying this accessible enough? By accessibility, we are talking about every level, the literacy for it, because you have people maybe who don't know how to read. You have audience who know, basically audiences who know how to read, but maybe they are not tech savvy enough, or maybe they are not also in terms of statistically and all these areas, they are not literate enough. So all these should be embedded. That's why we said human-centric. Users should be embedded in even your choices of your method, not because something is, you're using this method, it's accurate. Sometimes you might have to go with something that is less accurate, but it's explainable enough. It's understandable enough for someone to adopt this in terms of decision. So that's one thing I wanted to highlight a bit. So now that we've talked about the need to have accessible data representation or better way to present this information. So one thing we've mentioned in the headline, we don't have enough time to go deeper into it, is this idea of data physicalization. How do we explore data beyond the traditional visual space and making it more accessible to different audience? Let's say someone who is blind, let's say someone who is visually impaired in general, or let's say someone who is has hearing problems and all this. So we have different methods here. By data physicalization, we are talking about the processes where we use kind of digital fabrication, which means like digital objects or objects in the physical world as well. And in tangible ways, by tangible ways, we're talking about the sense of touch here, like in ways that they can be touchable, and they can change shape to have different representation. And the keyword here I've added is basically coupled with other modalities. So which means that there's no one universal solution. It has to be a mix of modalities, which is a cross modality. The best accessible solution are solutions that are personalizable, tailored to the end user. So that's why we are saying that it should be coupled with other modalities. So the focus here is on data physicalization. We have different methods. So by data physicalization, we have a few examples here. We have cases where people, back in the days, they have used a physical way of showing scientific data. And in case here right now, this person is presenting kind of a representation of what we call you said the Milky Way, the galaxy, the Milky Way, where you have the planets. So you have different, based on size, different representation of the planet. So let's say someone in some case, right, in this case, for instance, is blind, but at least the sense of touch they have, they can evaluate based on the size, the touch. Oh, Jupiter is bigger compared to Earth based on the size here. And you can also change the order. You put them in order of how they are located in the universe itself to show where the planets are positioned compared to themselves, to each other in general. So these are basically a way of, as a data scientist, you're representing the same way you would put this in a data visualization, you're putting it in the physical world itself. So you are not just touching one audience. Now you are making it accessible to different ranges or different audience. Even a kid can interact with this. It doesn't have to be someone who knows how to use a computer, who knows how to do this. Sometimes we need to move beyond the digital world and try to see the most tailored or personalized one. We have another one, which is very important. I'm also, as part of my work, exploring this idea of data sonification. So what if someone is blind or is visually impaired, and can we use sound to represent information or to convey information? A simple example of how we interact with sound in our daily life. I've shown the example of purchasing a coconut using the sound. We've done it, and we've done it for so many times. But another example is basically we've used it every day is the sound of your cell phone. You receive a call. You can make the difference between a call and a message. This is the simplest example of sonification. Your alarm, basically what is being conveyed to it, and it's a piece of information. The information when you set an alarm, you need to know is, I set this alarm at 5 a.m. So I want to wake up at 5 a.m. So this is the information. The data is the time. So you set this information, you set the data in your phone, and the phone now conveys this information back to you at the right time using sound. So you get the sound of the alarm, and it works. It's the simplest way of we are using other modalities, other senses to interact with information and data in general. This is another area that data scientists usually don't quite explore. You can have what we call sonification of charts. Basically, if you have a bar chart, you can assign a specific sound for each, because with sound, you have pitch in the sound. How loud is the sound? How low is the sound? You can, let's say you have a set of a series where you have data like 5, 10, and it varies. You have different level of your bar chart. You can assign now the pitch to the height of those bar charts to express basically the variation. And so you got a sound now that represents this variation. So these are ways you're making your data accessible. Another one, which is good right now, is the use nowadays of 3D models. So basically, you can print something into it. This one right here is an example of the United States map. So you have the map. You can visually see that this is the shape of a map if I'm looking at it. But at the same time, there are different heights on each of the states, which can represent different areas. So in this case, they were talking about the percentage of vote. So the highest, the shape of the state is the highest, the turnouts for the vote. So this is a model, basically, someone who is blind can interact with to get the same information as you would in a typical data visualization. Right now, one challenge would be someone tasks you to represent, because usually in typical data visualization, you use colors to assign this. You will use a different color, the hue. The more dense or dark the color, the more you have vote in this specific state. But what if now you can't use colors? Can you represent this? So I think we are running a bit out of time. But one thing I would mention to conclude, there's this concept as well where we are doing, with opportunity, we didn't bring it with us right now, this thing called tactile visualization of tactile graphic. So one thing it might be fun to look into is how do you basically teach shapes, teach patterns to visually impaired or people who have vision impairments. Without, how do you convey color to them? Let's say you have a chart, and let's say a simple example, you have the earth core, the earth. You're teaching to a kid who is blind. Because we are talking about accessibility. Accessibility shouldn't be not accessibility. An impairment shouldn't be an exclusion mechanism. So in the typical society, the way it works is if you are blind, you go to a blind school. So if you are visually dependent, you go to normal school. So technically, although we have methods, we have systems in place, but the system itself is excluding people. So remember, by having interaction, and it's the same thing with manipulation of data. By having interaction, you're learning more. So that interaction between those different groups can increase basically their learning processes. So you can have, in certain cases, basically teaching them, for instance, about let's say the Earth representation. You have the surface layer, you have the Earth core, and I forgot the layer in between, but you have the different layers. Usually, back in my days, the way you learn about this, they will assign color. The Earth core, where you have magma, they put the orange, very orangey color to represent the magma, and you have the surface layer. You have more variation showing the earth and water and everything. So how do you explain this to someone who is blind when you can't use color? And that's where patterns is important. People will be assigning a context to the color, and then this context add meanings for the color. So it's simple. You can explore this more if you look for the term tactile graphics. So this is a very important thing if you want to go beyond the typical representation of data. It might be very fun to read about, and also very good for self-reflection about how sometimes the way we are doing things can exclude people as well. So I will cap it here. I don't know if Alex has anything to conclude on this.
Yeah, I think we have touched on everything. So the key takeaway is, how do we make our data accessible? Can we use sound, sense of touch, etc.? That is kind of the key takeaway for today's webinar. So thank you, Paul. Now room for questions. Yeah.
Thank you, Alex and Peterson, for that wonderful presentation. So I think we are going to open the floor for questions. And Zafari Baha has been having a hand up for quite some time, so I'll give her the first chance. Zafari Baha, if you can hear me, you can proceed and ask your question. So anybody else who has a question, you can raise your hand and I'll be able to see that and give you an opportunity. Safari? Okay, if it's not ready, anybody who is ready? I think the floor is open.
Maybe I should be the one asking a few questions. But, maybe I can give an idea of people. It's also good also in those, I think, in those presentations, for it to not be more of you come and you get in the information, but also interact. It's more of an interaction. And I think I will start and probably ask a valid question to Alex, because we talk about the way we interact with data. It's not only data science in itself, it's basically every single field. So Alex, a question I might have for you, your research, you're exploring basically how people, or you can reduce anxiety for people, we are using electric vehicles. So how are you conveying your model response or that information to a user? Because I imagine if I'm driving a car, my attention needs to be on the road. So are you thinking of providing an accessible mean?
Okay, good question.
For this information.
Yeah, good question, Peterson. Yeah, so for now, I've worked on the model. So one way to convey my model outcome, or result, is through sound. So basically, I will kind of make an application, right, to connect the driver and the charging points. So now I'll be able to use an alert system to alert you, like in this point, we have a charging point. In this case, they are fully occupied. In this area, they have free ones. In this area, they are level 2 chargers. In this area, they are level 1. So through sound, I think I'll be able to convey, my model outputs more efficiently to a wider audience. Yeah, so sound, and as usual, graph and DTC. Yeah.
And also, one thing we didn't mention here today, when we were talking about data accessibility, there's this concept of haptics. So haptics is basically exploring your sense of touch. So a simple example of haptics is basically your phone vibration system. So when you receive an SMS, you receive like a very intense vibration on your phone. And if it is a call, you have a certain pattern. It increases, decreases, increases, decreases. So you can make the difference, again, based on the pattern, on whether it is a call or whether it is a message. So the information is being conveyed and you can differentiate for this. So this is another way as well people interact with information. You can use haptics as well to convey this. And this is something as well, I think, Alex, also you're thinking about exploring, like let's say on the steering wheel itself, like can you have haptics alerting you of certain danger because your hands is already on the wheels? Can you feel it in certain cases? That's a good point.
Okay. I think Eric Charlo has a question. He has raised his hand. So Eric, I think you can go. After that, I also have a question that I want to ask you.
Yes, thank you very much, guys, for your good work, and we really appreciate a lot. And my question goes to you, especially Wanamutua. Do you think Kenya is in a position to embrace the AI technology, especially like in these two fields, that is on the automotive and health sector? And if there are some things that we need to put in place as a country so that we can be able to harness much of what AI is giving us. So that's my question. And because I think you have the background of, you understand Kenya better. So thank you.
Perfect. Yeah. So looking at whether Kenya, we are ready for this stuff, AI in automotive sector or in the health sector, I would say yes, we just need a bit of acceleration. For example, if you look at Huawei has got what we call DigiTrack. That track goes to the 47 counties, teaching people about tech. And this tech, 5 key things: 5G, AI, machine learning, bit of networking, and IoT in the 47 counties we have. It's a mobile track with computers. You just go there for 1 month, you learn for free, you get your certificate, you go home as a happy person. Just gone. And again, if you look at Google, for example, led by this guy called Charles Morito, they have been holding, how we call them, Google camps, mostly in Nairobi and the Nyanza region. It has worked perfectly. What I would say is that our county government ICT team, they just need to up their game and kind of establish ICT hubs in every ward. That's number one, because we have to close the digital divide for us to achieve this. That's key number 1 point. We have to close the digital divide. So I would say that for now, we are moving towards there because I can see willingness by the government, although I've seen the government trying to open Wi-Fi hotspots everywhere. That might not help much. We just need concrete plans and policies. And then number 2.
Very good policies.
Yeah, number 2, we have got this office led by this lady called Kasait. It's a data protection office, They need to come up with proper policies and guidelines. How will data be used? Because we have so many ethical issues in AI and mostly in the healthcare. So for example, let's say you go to this hospital they are using an AI system to prescribe drugs for you. And by a mistake, this system gives you a very bad, poor or false, prescription. And then you go take the drugs, and by bad luck, someone dies. Will you sue the hospital? Will you sue the model? Will you sue the government? Who will you sue? So we need policies to close this gap. And I think when we get that one right and establish ICT hubs in every ward, I'm sure we'll get there. Bon Eric. Yeah.
Thank you. Thank you very much for your good answer. I really appreciate, and we hope our government is going to put in place those policies so that we can also prevent any disaster which might arise because of this technology. And
Yeah,
also,
correct.
I think in terms of our roads, so that it can embrace the technology of automotive, it needs some marking so that
Correct, yeah.
much of the we can harness much of it. Thank you.
Yeah, great. Yeah.
Thank you. Xavier, I think you can go first.
Okay, thank you so much, Alex. I have one question. You have just brought a very important aspect. In one of the forums that I attended recently, there was a discussion, as you know, that this AI and data science has led to a lot of ethical issues. And people have been complaining about the invasion of their privacy. Like perhaps when you're, even these social platforms such as Meta, X, and all those, we are sharing our images. We are thinking that perhaps you are celebrating a certain occasion. However, these images are used for other purposes without us knowing or without our consent. So there was a discussion on that there is a regulation that is being developed to regulate an algorithm, a machine learning algorithm. So I don't know, how is this something really which is possible? Can we regulate an algorithm? And perhaps I'm looking forward to hear your opinion with regards to that.
Okay, great. Yeah, so I would say we can regulate an algorithm. First of all, by the purpose. What is the goal? Yeah. So if we regulate the algorithm's goal, I'm sure we can be able to secure our data perfectly. For example, let's say nowadays, for example, like here, people are trying to work on around automotive videos about self-driving cars, etc. And part of it is that we having cameras everywhere on roads. They capture you, they capture everything for you, and they use that without knowledge. But if we are having good purpose, or good use of data with good protection, I think then we can be able to regulate algorithms. So the thing is, we should just prevent misuse of AI algorithms. And that's where now again, the issue of guidelines come in. I don't know if you can add something on that. Yeah.
Yeah. So I think that's a very, very important question. I don't know if it is you're referring to the EU Act, because the AI Act in Europe right now, there's after GDPR now with the certain increase of AI technologies in the last 4 or 5 years. So there were a few debate in the AI space whether should we stop AI now, AI development, or should we regulate it? Should we stop and try to regulate, or should we continue and regulate as we progress with the development? So it's a big debate. Even like the big names in the AI space, they couldn't agree on this. I think the problem is because often we build things without even involving the end users, and then we say later we'll fix it. I think it's a typical economy things, like you launch on the market, you see how it behaves, and then you can adapt. So it doesn't work much in tech or any things related with tech, because by then that particular piece of technology would have had even worse impacts or created so many harms, and it's even too late. Now you're trying to fix it. And it's the same thing with AI nowadays. Like we've seen, like with ChatGPT, we've seen with all this, and we were talking a bit earlier about the placebo effect. ChatGPT will by ChatGPT, we're talking about the LLM, the big language models. So you will ask them a question, and then they will reply with such confidence that in the end you say, "This is right. That sounds right," and this is called hallucination. So how do you regulate this? And we're going back into the digital divide. So we are talking about, you see, the problem here. We have the technology, and then now we say, oh, it's creating, it's having harm on people now. Let's regulate this. Oh, we need to regulate this, but the regulators now don't know anything about AI itself, or does it work, or does the whole AI thing work? So we are doing the whole opposite. So that's why we are saying in the previous question about how should, for instance, Kenya or the people of Kenya try to embrace these new things. I think the first step is we should learn from past experiences. We should learn one thing, therefore we can try to learn from the West is this. Basically, we should start with, first of all, digital learning and in the government spaces or public sector itself. Because if you have people creating those policies and they don't know what they are doing, they don't even understand those technologies, we are not going anywhere. So you need first proper digital literacy within your public sector, so that you have a new class now of leaders or decision makers that understand not the functioning of, the whole total functioning of those technologies, but understand the rationale behind technology itself. Therefore, they can inform those policies or create those policies so that can help regulate the development, the future development of those AI. Things like, how should you define your AI? What should be the process of a new company developing, for instance, an AI predicting skin cancer in Kenya? What should be the process for this? But first, these decision makers, they should understand how these things or these technologies, they interact, or do people interact with them? They should understand the underlying aspect of these first in order to create those regulatory policies first. And I think we should start from the users first, moving towards the solution, not the solution first, and then adapt it to user. It doesn't work in many cases.
Just to be bottom up, from the user upward. Yeah, great.
Okay, thank you for that. So I think there's no any other questions. So I'll ask one question, and then I think we'll conclude at that. So from my understanding of the explainability AI, or the explainable AI that we talked about, basically it focuses on making artificial intelligence systems more understandable and transparent to the human beings.
Yeah.
So with the improved understanding of how the hidden layers of machine learning model works, I tend to view this as a creation of a possibility or acceleration into the creation of sentient machines. So are you seeing us in the near future being able to create sentient artificial intelligence? And if so, how are we to deal with this? Because with sentient machines, I think the human race could be at risk. So maybe just your view.
Now, we just talked a bit about this. I think earlier this year, we had this big debate between the top AI guys in the world. We had Yann LeCun, we had Jeffrey in the US, which is considered in the Canada, which is considered as the godfather of AI. So there was this whole debate, are we moving towards, more what we call, the term here is basically artificial general intelligence, basically a system that can interpret on anything. And when people have seen the progress made with OpenAI, ChatGPT, now ChatGPT, you can input any information, ask, interact with speech. You have different modalities, and we're talking about the modalities. So there's a bit of debate. Are we moving towards this? And there was a graph, we didn't put it on the slide, but there was a graph about what we considered as basically the number of processing power, technical number of processing power of the human brain, and kind of the exponential increase now for our computers in terms of flops and processes.
Yeah.
We are new in there. But at the same time, we are closing this gap. People might say, oh, we are moving towards artificial general intelligence, which is kind of usually called as computers being sentient, having a conscience and everything. But the problem is you still need the human. Okay, you still need the human in certain cases, because the human, one thing we are good at human is like differentiation. Like in certain case scenarios, we can quickly interact and make a sense, and that's why in certain cases people will call it free will or call it, we can decide whether we want to go with it or not. Whereas the AI, if it is the right thing, if it needs, let's say, needs to kill the person, it will kill the person because this is what the model is supposed to do. But as a human, we say, no, this is not good to do because we shouldn't be, you can reason on this. And this is kind of reasoning. Whereas the AI, people might think that, oh, if you tell the AI, now, as we are moving into more systems like this, like people are creating now, a lot of research is being done in the area of humanoid, which is basically robots that look like humans. And in terms of dexterity and everything, it's very complex, and we're not there yet. Although we have the computing power, because that's the difference nowadays. We have the computing power, but you don't have, because we're talking about different, we call this degree of freedoms and interactions. Like if you have humanoid robots who have insane computing power, but when you look at those robots doing certain tasks, like can they look on the surrounding, hear the sounds, and then react on this directly? That's where we're not there yet, and we still have a lot to do. Although we have computing powers, but different interaction of those modalities is not there yet. So I don't think humans are replaceable in the process. We still need a human, but it's the same thing. Like let's consider examples where it happened back in the days. Like people were saying, okay, you don't need let's say books, when books became not obsolete, but people were saying, oh, now we have digital books and everything. Does this make, the old books, they are irrelevant? Are they relevant? Not, but depends on the case scenarios. You still need it or not. Because what if you don't have internet? What if you don't have certain things, or you're in an area where you have limited access to certain piece of technology? You still need it. So I think technologies now is more becoming, I would say, more tailored. We need to move towards more tailored solution rather than saying that we are replacing human.
It's okay. Thank you. Thank you, Alex. Thank you, Peter. I think it's been an honor having you. Maybe we'll organize more of such webinars in the future.
Yeah,
so that we delve into these more.
Yeah.
Thank you guys for joining. I think we'll conclude at that point.
Yeah, thanks everyone for borrowing us your earrings and your ears. So it was a pleasure, and we really enjoyed this, and we hope you've taken a few things from these and you can explore yourself. Although these are very surface levels, but you can dive into details yourself. Yeah, and also good luck in